Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome, please. Diagram is a graph of the function y is equal to 3 minus 2x minus x squared. Then when you look at it, you can see that this is our x-axis, this is our y-axis, and then this is the graph that has been plotted out of the function y is equal to 3 minus 2x minus x squared. Then we have these points. Point P is a point at which the graph is cutting the x-axis. Point R is also another point where the graph is cutting the x-axis. At the points where the graph of y cuts the x-axis, it means that y is equal to 0 at that point, meaning at the 2 points P and Q, y is equal to 0. So we are asked to find the coordinates of P and the coordinates of R. So we'll start with those two. Those two can be actually answered simultaneously. So using this working space, if x is not equal to 0 there, but y is equal to 0, meaning that this equation can be equated to 0 because y is equal to 0. Say y is equal to 0. Then our equation, it will be a quadratic equation, hence we have negative x squared minus 2x plus 3 is equal to 0. I had to just rearrange it. Nothing changes. Then identify the coefficients a, b, and then also the constant c. Our a is going to be the coefficient of x to the power 2. When we say coefficient of x to the power 2, we are talking about a number in front of x to the power 2. The number in front of x to the power 2 in this case cannot be seen. We can only see the negative, meaning the coefficient is actually -1. So we say -1. The next coefficient is coefficient b. Coefficient b has to be the number in front of x to the power 1. Which one is x to the power 1 here? This is power 2. There is no x. We can't see the power there. You can't see the power. Then it means that there x is to the power 1. So the number in front of this x to the power 1 is -2. Our b is going to be -2. The constant c. Constant c is a number that remains the same, or a number without a variable x. In this case, 3 is our constant c. After doing that, you can now substitute these into the quadratic formula, which states that x is equal to -b plus or minus root of b squared minus 4ac over 2a. This is the quadratic formula. Please make sure that this bar graph, which stands for division, reaches this point. It should not end up to there. When it ends there, it means this -b is over 1. But this 2a caters for everything. It is the denominator for everything. Then you substitute into that. Your correct identification of these is very important. Your correct substitution into the quadratic formula is of great importance too. So we'll say x is now equal to -b. Our b is -2. Remember, there's a negative there. There's another negative there. So this negative will still be maintained. Negative, then there's a negative there. So -2, close brackets, plus or minus root b squared. Our b is -2. So -2 to the power 2. Make sure that the negative and the number 2 are enclosed in brackets, then you raise to the power. Okay? Then minus 4 times a. Our a is -1. So -1, then times 3. 3 is there. Over 2 times a. 2 times a. our a is -1, so -1. Like I said, the bar must be reaching throughout, which is the division. Then the root also must be enclosing everything like that, not ending up somewhere. No, it must enclose everything. From there, let's do the possible multiplications. Negative times negative, positive. So we have x is equal to 2 plus or minus root of. Negative 2 to the power 2 does not mean negative 2 times 2. It means this negative 2 is multiplying itself how many times? 2 times. So meaning negative 2 times negative 2, which will give you a positive 4. So we have a 4 there. Negative times negative, positive. So we have a positive here. 4 times 1 times 3 will give you 12. So we have the number 12 like that. Then over 2 times -1 will give you a -2. So we have a -2 here. -2 there. Then from here, you deal with what is in the root. 4 plus 12, 16. So this comes to x is equal to 2 plus or minus 16 over -2. I have to explain why we put plus or minus there. It means the square root of the number inside this root can be a positive number or a negative number. Hence, there should be two ways of mathematical operations, that is plus or minus. Then what is the square root of 16? It's actually 4. Hence we have x is equal to 2 plus or minus 4 over -2. There we have two mathematical operations. Like I said, it is a two-way mathematical operations. And as such, from here we are going to have two values of x. There will be x1, which is going to be equal to 2. Hence, this will be 2 divided by 2, which will be 1. So we have a +1 and a -3 for the answers. After getting that, you have to come back to the diagram. On the diagram, the y graph is cutting the x-axis at 2 points, on the right and on the left of the origin. At the origin here, going to this side, it's positives. From the origin coming this side, it's negative. Meaning that the value of x at r should not be a negative number. It will be a positive number. And the positive number that we have here is this 1. So at r, x is equal to 1. 1, comma. Then at p, p is on the left. So it has to be a negative. So at p, x is equal to -3, comma. Now let's consider what are the values of y. We said that y is supposed to be 0 on the x-axis. If y is supposed to be 0 on the x-axis, then it means that at both points y is equal to 0, 0. Hence at p, the coordinates are -3, 0, r 1. At q, looking at the position of q on the graph, it is a point at which the y graph cuts the y-axis. And it is not cutting the y-axis at the origin, meaning the value of y at that point should not be considered to be 0. The value of x is actually a positive y because it is above. Then, in terms of x, throughout the y-axis, x is equal to 0. If x is equal to 0 throughout the y-axis, then we are saying for c, x is equal to 0 at this point. If x is equal to 0 at that point, then we can consider that y is equal to 3 minus 2 times 0, minus 0 to the power 2, because x is equal to 0. Then we have y is equal to 3. So the value of y at this point q is 3. So we have 3 What about x? We said x on the y-axis is equal to 0. So we have 0, 3. Method 1. Method 1. If we have to consider that this is a turning point, then it means that at the turning point, the gradient is equal to 0. So y is equal to 3 minus 2x minus x squared. That is our function. Then the gradient of this function should be equal to 0 at the turning point. So you use calculus, you differentiate this so that you find what we call the gradient function. So we say dy over dx is actually equal to, this 3 is a constant. When we differentiate it, it becomes 0. So this is a 0. The power of x here is 1. So you say 1 times negative 2, it will give you negative 2. Then x to the power 1 minus 1 is 0. Okay? Then this power here will multiply again the coefficient. 2 times negative 1 is negative 2. Then x 2 minus 1 is 1. Then this means that we have, according to indices, any number of variable to the power 0 is equal to 1. This makes us also conclude that this x to the power 0 is equal to 1. Then we have a negative 2 times 1 minus 2 x to the power 1. We do not write the power 1, we ignore it, so we have x. Then from there, our dy over dx is going to be equal to negative 2 minus 2x. I said, at the turning point, gradient is equal to 0. At this point, what we have found is the gradient function. Hence, this gradient function is actually equal to 0, because at the turning point, gradient is equal to 0. Collect the like terms. You have negative 2x is equal to 0 plus 2. Negative 2x is equal to 2. Divide by negative 2, divide by negative 2. You have this and that going, then x is actually equal to negative 1. This means that at the turning point, x is equal to negative 1. If x is equal to negative 1 at the turning point, what about y? Go back to the original function. You say y is equal to 3 minus 2 times x is equal to negative 1 times negative 1, then minus x squared, which is negative 1 to the power 2. From there, this is going to give you a 3 plus 2 minus 1. I'm sure you're able to follow that. Then at that point, we're going to have y is equal to 5 minus 1 is 4. So our x is this, our y is that. At the turning point, x is equal to negative 1, comma, y is equal to positive 4, comma, positive 4, like that.